Okay, cool. Standard copyright slide. Assuming that's the way. So yes, this is a fairly short presentation that I'll give you about some work that we've done since a similar presentation that we did a couple of years ago. So the intention for this presentation really is as a jumping off point for hopefully a relatively heated discussion. So let's see whether we can get into the heated discussion. The overall view of the presentation is in front of you. I will swiftly move on. So actually, in my mind, this picture is kind of summing up a lot of things, not least of which our experience at DVCon. We are struggling to communicate with each other. There's a degree to which that's because we're in virtual environments and so on and so forth. But there's also a degree to which, even if we consider it the kind of the meta level up, we are, as a community, the SystemC community, not talking to many of the other simulation communities, and those communities are not talking to us. I was at a meeting, and this all sprang off from a meeting that I had, some 3 years ago now, where I discovered an entire community of people who had built a standard that, if you squint and look sideways, is exactly the same as SystemC TLM. And they were asking whether there was a model of a fairly simple CPU device. And I was there actually with one of the BARTs, and we were both literally scratching our head thinking, what's going on here? Of course we've got models of that. But it turned out that in that particular community, that model didn't exist yet. And that got me thinking, we really do have a problem there. There's clearly, you don't want to have to rework existing IP blocks. We really need to jump out of our silos and work out how we can communicate with each other. And in order to do that, first of all, it's just purely a human problem of communication, which is one of the reasons why I was so keen on getting people to talk to each other in the virtual rooms. So the problem statement, basically, all of our industries, and this particular case was SMP2, all of our industries are building different standards. So some of these you'll have heard of, and potentially some of them you won't. So I think FMI, FMU has already had a mention today, and I'm pretty sure most of you should know about OpenADX. And of course, you're all very well aware and familiar with the SystemC standards, but how many of you have used SMP2, and who knows very much about VHTNG? By the way, both of those two things look remarkably similar to TLM. So the problem statement is really, what can we do in order to get these various different domains talking to each other? So we've put together, and I have to say, yet again, I am thankful to Martin. We have put together a kind of a small initiative to bring these various different actors together and to really foster some sort of cooperation between the various different people. Where are we today? Well, we'll come on to that, but we haven't really moved very far forwards. But just to kind of give a little flavor of, so what are we talking about? Some of these standards are absolutely at the same level of abstraction. Other times the standards are not at the same level of abstraction, yet you still want to be able to simulate an application that you have written at a high level, obviously in the application domain, and you want to be able to simulate that with other components at different levels of abstraction. And at the moment, all of these links are tenuous. Very often they're solved within one vertical, but they're certainly not solved across the piece. So the current status, we had a workshop, where are we now? Yes, we had a workshop at DVCon Europe 2020, which isn't actually that long ago, where we kind of talked about this, and some parties expressed some interest. And we formed a kind of a core team of people who looked at this, and we've been looking at it for the last year or so. So that includes myself and Martin. It includes Bosch and Airbus and Spacebell, and so on and so forth. We've kind of defined a few objectives. We've kind of defined a little bit what the charter is, if you like, and we've kind of started to investigate the landscape of standards that are out there and how things could connect together. So that's where we are. And I suppose what you could say is that in almost all cases, what we discover is either a set of standards like OpenADX, which works reasonably well through a vertical, or we discover a level of abstraction, if you like, which would work across the piece, for instance, TLM2 and actually SMP2. Or we discover kind of point solutions which work at various different places through the hierarchy. So FMI, FMU is a great example. It works brilliantly for what it does, but it doesn't necessarily solve all the problems for all the people. Okay, so I said at the top, this is a short presentation, and the plan is to spark a big debate. So I'm up for that big debate. I'm going to press this button here so I can see some of your faces at the same time. I don't know whether that's going to work. Oh, have I stopped sharing?
No, it is still on.
You can still see, but you can see. Okay, fine. I can't see. Oh, that's a bit of a shame. I thought I should be able to see some of you guys as well. But yeah, so the first question is, what things are you doing? So yeah, I'd like to hear. I think the chat is open, but equally, I'm hoping that the actual voice is open as well. Please jump in and shout. What standards are you currently using? What simulators do you currently aggregate together? Are you doing hydraulic simulation as well as electronic simulation? Do you handle different timescales, et cetera, What standards are you currently using? Yeah, what issues are you facing with those? So yeah, I would like to throw it open a little bit at this point. Always dangerous. Who's going to jump first? Nobody. Martin, you can go first.
Okay, so, let me give a bit of direction on what we like to get out of this discussion. The challenge is, like Mark showed, there are different industries, different standards. So we might be tempted to say, this is all not fitting. We are going to invent yet another standard. And in the diagram, which was on the previous page, we might create yet another horizontal line or a vertical line or a block in the space. So although we might say, yes, no good match, let's invent something which can rule the world, one standard that rules them all, might not solve the problem. At the other end, if we say, okay, we need to somehow deal with the existing standards which were listed, it would be great that to those standards we can build a sort of connection, extension, a mechanism to talk to another standard, but that requires that we somehow get connected to all those other standardization bodies, which might be many, and it will take probably months, years, or decades to get something up and running. So we really like to get a bit of feedback on, okay, should we somehow get the best pieces and build another standard? Should we build upon existing standards or something in between? And I think the verdict is still out on what would be the best mechanism to do it. That's the technical discussion. Then in addition to that, there is an organizational discussion. I think it is not listed here on the slide, but if we have an idea on how to do it, which organization, body, institute, whatever the name of the body is, has the scope to do this. Because at the end, it's nice that we have a core team, we have different industries coming together, but such a multidisciplinary initiative requires also an organization which is somehow connected to those industries. And you see that standardization bodies are also having their focus in a specific domain. So it's the challenge is as well to find a home for this initiative. So I'd like to get your feedback. In addition to the questions here, what is your preference? Yet another standard or an extension to existing standards? And if you have suggestions for an organization where this who can be, let's say, the host to drive this further, that would be also appreciated.
Well, I can share some thoughts on this. Today we have the SystemC Evolution Day. So let's say in principle, I would say we are looking from SystemC point of view in as a starter. So I would say that the minimal that we have to do as SystemC standard developers is to open up, and I'm not talking in terms of repository, but I'm talking about in terms of hooks into the code, open up as much as possible so that other standards or interested standards that that are interested to connect to us have an easy job to do. So that I think that's one thing to at least survive in any case in this world of hundred thousands of standards. So that's one thing. And the second thought is that that's the cathedral and the bazaar thought, is that indeed you cannot have one big organization that is forcing everyone in the same in a certain framework, but I would expect that these intercommunications between standards are could be a bit ad hoc, and you could by coincidence walk into a standard in another environment and think, hey, it would be interesting if we could connect to each other. And in that way build and organically build connections to other standards. And in that from that perspective, it helps, of course, then to have all the hooks that you can have into your own code for other people to connect to.
I think you very much said very much what a lot of us have thought through the time in terms of how this might end up going. So I personally, I think you're pretty much right on both fronts. But yes, let's keep going around. I will go down a little bit.
I'd like to comment on the second item on how to intercommunicate between different standards or standards body, and that can be a bit ad hoc initially and grow over time. That's a bit how I understood the feedback. We more or less did that. And I think that might not be enough. So yes, there is a bit of, we have some connections to, especially Mark, connections to the Airbus world. We have connections to Andy and the Open ADX, but that's all a bit loose at the moment. It's not yet. I think it's great that we have ties into that, but the question is that enough? My personal view is that we might need to formalize it a bit more. Not that it gets heavy, but at least that you might want to have a sort of official relation between the Eclipse Foundation and Accelera, perhaps. That those bodies recognize each other, and there can be some sort of yearly or quarterly alignment on certain topics. I don't know. So yes, it's good that there is ad hoc and the first things are established. Is that enough to build a sustainable ecosystem? I do not think so. I think we need to do a bit more. What that more is, I don't know yet.
I totally agree. But I didn't hear that it would just be an ad hoc kind of let's discuss it. There is going to be engineering work that's needed. In my opinion, one way or the other, there'll be engineering work needed.
Yeah, I think if I can comment on that, because I mean, for me, this discussion so far is a bit abstract, but that's because I'm not familiar with all of the other standards. So what I know that is that often in these kind of situations, there is, let's say, a demonstration vehicle or whatever defined, which tries to integrate a number of models from each of these standards, and then summarize in more detail what problems have been found and what possible ways there could be to solve those problems. At least for me, such an approach would be, let's say, more practical and more grounds up, and would, for me, lead to more insight than top down, diving into the standards and see how they fit to each other.
Yeah, from my point of view, this is a really good approach. So let's start with implement, or let's do something. So typically in the open source world, you have the code first approach, and then the standard will come afterwards. So this is what you mentioned. Let's start bring things together. Start with small steps. Think big. And that's the way from my point of view. I really appreciate that we have here a collaboration, because collaboration is exactly the key for such things. The framework on top of that, I guess it's the second question, and I fully agree with Martin. It should be a bit more formalized. The format, yeah, that's really open. But I guess also we need here more confirmation on that, so that the people are willing to work more on that or work together, because I'm really sure we are solving with the standards more or less the same problems, and or in the same problem space. And let's find then with some activities the overlaps, and hopefully come to a base which maybe is 50% of all the standards, who knows, and keep on going there.
Yeah, I have a slightly different take on this, which is more like, if you look at this from the perspective of an individual organization, the thing that matters is that you get some good thing into which you can slot all your simulators, right? And that's my experience in just banging things together, is that as long as you know, kind of, if there's one substrate you can target, that gets you a long way, and then it's just a long number of ad hoc translations, between them. But if you're only doing that once for everything you integrate, honestly, that's fine. Right? The problem becomes if you have to do, many too many connectors, then it just falls apart. But in a sense, it doesn't matter what the underlying substrate is, as long as you just decide as an organization to have one of them.
Yes, it also depends on which organization and what you're trying to integrate. As you say, many to many is a total nightmare, and you might be in a situation where you can decide on one. Many other people are not in that situation. I think that's kind of one of the questions on the table, is the degree to which organizations are currently in pain because of this. I guess this is the wrong community to ask that, because we've all chosen one of these particular standards, right? But Andy comes from a domain which is slightly different, where you haven't chosen this particular standard, and it's one of the standards that you'd kind of probably like to connect with. So yeah, I mean, I think you're right, Jakob, but I don't think that everybody has that useful and lovely situation, as it were. Should we move on a bit?
A quick word on this demonstrator bottom-up approach versus top-down. Yes, it's good to also look into that, but I like to avoid that we make a demonstrator with spaghetti interconnect. Yes, it works. Is it scalable? Probably not. So in that sense, there needs to be a healthy balance between top-down, where the thing is architected, and bottom-up, to test it. I did like the comment of Andy on having this bit more formalized organization. He used the word commitment. I think that is the right thing. At the end, we as individuals can be very enthusiastic, but how do I get my boss or the boss of the boss enthusiastic? And that we as an organization can join, and the organization start to cooperate. So bringing it from the individual level to the let's say organizational level, and then yeah, building a demonstrator is nice, and if we recognize that, then we need to still sell that message to our management. That because the demonstrator doesn't fall out of the sky, it's serious work, it costs money, exactly. So it's a bit of a chicken egg problem. Yes, we recognize all that we want to make a tangible demonstrator, but who is going to put the resources on the table? I think the discussion Mark and I had with some of the other companies is we were exploring, is there a European project? Is there another form of collaboration possible where there is funding? Because if there is funding, then there is also things where we can assign resources to it. So that is, I think, where the organizational element kicks in, that without having some sort of structure and commitment and allocations, then yeah, getting a demonstrator up and running, as simple as it is, it might even be a challenge.
So what you're saying is that maybe it's better to start with a project that does this for some concrete case, learn from that, and that might in turn later on lead to some kind of standard.
Possibly.
Yeah.
Yes, it's always good to, and I think both, I've seen cases in standardization where both things work, or have their pros and cons, actually doing a standardization top down or doing it bottom up. Here, I think we need to come up with a good plan, a good strategy, and also a convincing story, and to go to Brussels, for example, and say, guys, we have a consortium, this is the objective. And so anyone who has a good idea and is connected to either local or European standardization initiative, please speak up, and we need to see if there are opportunities in that area as well.
Okay, I'll tell you what, I could be very cruel and call people out to answer the questions, but let's move on and see whether we get a little bit more engagement in a minute. Am I still suitably sharing the screen?
Yes, you can go to full screen, Mark, although the fonts are big enough, but.
If I go to full, well, yeah, okay, I can probably do that.
Yeah, whatever you like, it's readable. Keep
okay,
it. Keep
so
it.
yeah, there's only a couple more slides anyway. At the moment, what you've said, actually, what everybody has said was reiterated a little bit in this statement of what we were trying to achieve, which is very much about coordination and cooperation between the existing open standards. So that was kind of the message or the tagline that we were providing ourselves with. The next steps, which is kind of exactly again what we've just been talking about. Clearly, at this point, it's a fun group of individuals who are trying to push this agenda forward a little bit. But we need some concrete goals, and we need to decide to the degree to which we want to go bottom up or top down. And I think at this point, yes, some bottom up work is clearly needed. And we also need to have a host place, as Martin says. There needs to be something more concrete that you can get your bosses engaged with. There's the opportunity, and we have Andy on the call, there's the opportunity to be part of the Eclipse framework, potentially within OpenADX, as one possible option. Whether that's appropriate or not, that's one possibility. And then we need to agree on the technical approach, and indeed, if we're going to take a single example initially, or whether we're going to look for a more generic approach. So then the question that actually Martin raised the other day, which I think is a very interesting question, why are we talking about this at the SystemC and SystemC Evolution Day? What's the role of SystemC in this? So SystemC already defines a model there's already an execution semantic. There's already kind of some of the things that you might need to communicate with each other. But the issue here is you could say this about pretty much every other standard as well. And I think where we were trying to go with this, I don't know, Martin will probably speak to this slide too, but where we're trying to go to this is very much actually what was said earlier. The point is that SystemC needs to be very much more open, or more, it needs to be open to the connection to the other standards. But there is a defined semantic, there is a defined abstraction of communication. And we are pretty rich in terms of being able to classify different simulation semantics and classify different ways of communicating, and support those through the SystemC and the TLM framework. So it's probably not a bad place to start in terms of trying to communicate with other standards. Martin, did you want to say more on this slide?
Yes, I think besides that, that SystemC is a standard and it has defined all these areas or extensions. I think what is pretty unique, if you ask me, is that we also have a reference implementation of the simulator, which is tightly coupled to the standard. If I look to some of the other standards in the other domains, they have focused on interfaces for interoperability or a definition on metadata, but then they basically align with partners, EDA partners or tool providers in their industry that support that standard. There is not a sort of open source simulator out there. I think that's a bit of a unique case, what I see with SystemC. There is the simulator, which is maintained by Accelera. And of course, the standard is leading, but there is a prototype available for prototyping, for demonstration, etc., and which is unique. So we can say to other industries, oh, you're looking for a system simulation framework. Yeah, okay, this was tuned and geared towards semiconductor, but if you want to model an hydraulic system or another type of system, of course, we need to find out whether the communication and extensions are appropriate, but then we can give them a simulator for their ecosystem besides the commercial offerings, which can do much more, obviously. We know that the SystemC simulator is not, let's say, the state of the art, but when it comes to, okay, getting such an environment up and running and dealing with gluing different tools together might be a challenge as well. So we better start introducing SystemC as a simulator in other industries. But we then need to understand, okay, what type of communication goes back and forth at the simulator level, and do we have the right API? So besides the standard, I think we have an additional joker card in our hands, which is the simulator itself.
I'm not absolutely convinced that we're totally unique in having an open source implementation, and you might want to jump in and confirm or deny. But I also think that we bring one other thing, which I think is pretty unique, and that's AMS.
But which other, which other standards do have then an executable along with the standard? Give an example.
Model MTX not available openly?
Yeah, OpenMCX is now available since some weeks. So it's relying on what standard, FMI, DCP, SSP, which they support. It's based on the AVL Model Connect framework, so it's a co-simulate or partly Model Connect in the open. Not the complete framework, but partly. Therefore, you can, I can post a link later on here in the chat, and you can use it. And
is it already a standard, or what is this? I am aware of this movement, but is it? Would we already call that a standard? Is there an API? Is there an IEC label connected to it or something like that?
You mean to OpenMCX or the Model Connect framework? No, it's more on the support of the standards like FMI, FMU, SSP, DCP, what they are using in there. So you can use that, and you can use that for, of course, and FMI is a standard.
Okay.
I know the simulators are typically more focused on their use cases. Means they are, I guess, not really focused on here analog or mixed signal system verification. They are more a bit focused on other stuff. The same is there's also another open source simulator out there, or many. It's called Kala. Kala has a 3D engine in there and is often used for cars or some vehicles. Then there is Sumo, but it's more for the traffic simulation, so that you can here have a look how the traffic will evolve within a city based on their maps. But it's also out there then from Microsoft. They started with, now I forgot the name, sorry for that. They started with a simulator for drones, and they adapted it in an easy way to vehicles. So the advantage of the open is that you can easily adapt that. It's the same for the standards. So you do not have to define for everything something new. You can use what there is, and you can adapt it to your needs. That's the big advantage of open source or open standards.
But I think actually, what, as you were saying, I mean, we don't cover traffic necessarily, nor car simulation, what was the 3D simulation.
Yeah.
But the fact that we already have an analog and mixed signal integration, and we already have system verification components, I think makes the SystemC story quite robust and quite round. I think the point at the bottom is exactly right. SystemC should be one of the standards that connects to the others. The fact that it's open and so on and so forth. But why aren't we yet connected to Corolla? Why aren't we yet connected to Model MTX? And the reason, probably more than anything else, is that we just haven't talked. Right? The people haven't talked together yet.
Yeah,
and maybe we need to talk, but then talking isn't going to be enough. We're going to need, as everybody's pointed out, we're going to need some actual work done to align the things.
Yeah. Well, I mean, I would like to kind of advocate opposing view, is that having an actual implementation and all the features of SystemC is a drawback, because it would mean that integrating with it means following many more rules than if you take the more traditional, let's standardize the interface. And that's just, here is, a minimal interface definition, and you can build your scheduler any way you want. Inside of your binary, everything is whatever you want, as long as you talk the right protocol to the outside somehow, and we all agree on some minimal things. And at least to me, I think that is more useful, especially when we talk about truly multi-domain simulations, than kind of forcing everything to use. You get so many side effects if you want people to actually use SystemC semantics, where you have a threading semantics. We have this whole discussions about parallelism and everything, right? That complicates things. So I am a huge fan of standardizing the interfaces and leaving the internal implementation to be whatever people want. And SystemC is a mix of both, right? I mean, SystemC TLM is an interface standard, but it typically is used alongside a SystemC runtime as well, right? Even though in theory you could
kind of has tentacles to the model, but it kind of implies that you're going to do things inside the model in a particular way. So I kind of agree with you. And the other thing which I would say about SystemC, which is to its detriment, in my opinion, is that you're talking about the interface between SystemC and other things. We haven't got one. As far as the SystemC world is concerned, it's the SystemC world. There are interfaces between components within SystemC, but as far as I'm aware, there's no real interface between a SystemC model and the outside world. The only way you could do that is to have the outside world, whatever it is, represented as a SystemC model, and then black magic could happen inside that that thing. But from the SystemC perspective, that would then look like yet another SystemC model. There's no concept in SystemC of a foreign object and an API to a foreign object, as it were. There's no synchronization mechanism. There's no plug.
That was exactly my remark regarding opening up as many hooks as possible into the SystemC environment.
What I would like to add, I like the idea of having here the standardization in there, because this is also what we, so to speak, force within OpenADX. So we know to define, for example, the one and only toolchain that will not work, because everyone is familiar with other tools maybe, and you have to create a framework where everyone can use their own stuff, so to speak. Means it's also a question of where to put the borders from your system. Yes, you need some interfaces to the next level, so to speak. You need levels, interfaces within your area, within your framework, to bring that stuff together, to be possible to exchange some things. So for example, that you have on the one hand SystemC, maybe on the other hand you have something others. I'm not sure if I'm right, because I'm not deeply in that stuff in there. Yeah, maybe you have a VHDL on the other hand, and if they are concurring, yeah, let's find a way to make here a common interface so that you can use whatever you want, whatever best fits to your personal flavor, to your working environment, or how you want to work in this area, and what fits best also from your company perspective.
And I think in the past, the kind of tacit understanding that we had when SystemC was first invented, as it were, was, well, actually, this is just a C interface to an existing mixed language simulator that we hope that the EDA companies will provide for us. And as it were, the expectation would be that there was one big flat support structure provided by this simulation engine, and then we would be able to add our SystemC models onto the top of it. But where we're ending up, in my view, my opinion at the moment, is it's not quite as clean as that. What we seem to have is, well, there's a SystemC simulation over there in a corner, and there's an FMI FMU model over there, and then there's an SMP3 model over here, and all of these need to connect together. And there are standards being proposed, or at least there are ways and means being proposed of connecting these things together. But at the moment, I think one of the things we are sorely missing in the SystemC community is an external API. And I think that's kind of evidenced by the pain that we're currently going with in terms of the language working group, and the so-called unsuspend interface is part of this story, giving us a mechanism by which we can at least synchronize with the outside world. And I think probably we are at a point with SystemC where having some sort of external interface so that you don't wrap up VHDL inside SystemC, rather you have a way in which you could communicate with an external VHDL simulator or an external hardware in the loop, to me would make some sense, and we don't currently have that. Yes.
I think that is already part of you're probably already explaining a bit of the next slide.
Yes, let's do the next slide. So yeah, some sort of publish, subscribe, for instance, some sort of adapter, for instance, that goes into SystemC. Yeah, I've just explained the next slide without having the next slide on, haven't I? So that's always the best way of doing slides. But yeah, the idea being that then we could bring together these various different silos. But yeah, which one to use, whether we should choose one, whether we should, from the SystemC's perspective, drive one, or whether we should be driven by one. I'm using the word drive, looking at somebody from OpenADX. Please remove drive from the previous sentence. Yeah, I think the questions there are about exactly what we should build as a SystemC community. I think Baz is absolutely right. I think we should be as open as possible. And I think we need to be able to provide the links to be able to hook to different mechanisms on the outside, whether they are indeed publish subscribe or whether they're different mechanisms. But Martin, do you want to jump in?
Yeah, in terms of a bit brainstorming on the lower part of the slide on the different standardization options, I think you touched upon it. Okay, what if we want to have a standardized plug or adapter? At which level? What are the requirements, and does it require kernel changes? And then it's more like you said with the suspend resume concepts we might need. We can do it at more at the communication level, that we consider it's more an abstract TLM type of interface. Doesn't fit those two areas? Does it need to be a dedicated extension? Is there a sort of, do we want to make a plugin or an extension to SystemC which can say, okay, we are going to have a publish subscribe model, or it's going to do it? Or if we might even say, that's probably the scenario we are currently in. Yeah, we don't know. We leave it up to the desk of the modeler, and then it's in the application space, and then there is no standard. So that are a bit of the four ranges. Not that we need to pick one, but it can be a combination. But it depends on the use case and the abstraction level of the type of communication with what goes over the bus. And I think there, that is what is question 2, is what type of intercommunication standard infrastructure are we going to use? There are different publish subscribe standards out there, and also there we need to know, okay, if we agree, let's make an adapter. Okay, that's nice, but where should it adapt to? And do all those industry have a common understanding on the underlying communication protocols? Or do we have multiple of those? So that is another question we need to answer, but that requires a discussion with the other application domains, obviously.
And we've mentioned the unsuspend thing, but of course that's kind of, well, I suspect at least that's probably pretty, for want of a better word, digital. Carsten, you're on the call, and you might be able to talk to this, but from the AMS perspective, I suspect that that communication and that publish subscribe model would have to look very, very different for it to make any sense at all, to have devices connected where some of these models are in fact AMS style models. I was hoping Carsten would pop up.
But Mark, don't you really think it's a matter of kind of all of the above, right? Because I mean, you're talking about the time sync facilities in the core itself, right? I mean, that definitely would be needed. So you could take a SystemC based simulator and you can control time from outside. And then you would probably also need things like, or you would see adapters of TLM and AMS for particular types of messages being sent to whatever the external thing is, right? So you would have a SystemC support for being part of a distributed simulation, and then you would have, you know, domain-specific adapters so that if I am talking to FMI and we happen to be exchanging, you know, the mechanics of an engine, well, maybe that slots very nicely into AMS where you have your sensor model. Or if what you're doing is sending out, you know, GPIOs, that's just channel the whole thing to TLM, and you would have like a TLM FMI adapter package, something like that, right? Which would be not really part of the standard, right? But it would be what you would end up with in the end, I believe, right?
And then the question, I suppose, is who owns building these things, and where does that all happen? Which comes back to the question of where does all of this live? So yeah, you can tell we're in the process of putting this forward and moving forward with it. We're in the process of needing more people to to come up with better ideas about where we go next. We're also in the process of hunting for some means by which some of this work could be funded and moved forward, and ownership for it. Like, is it going to be owned in an Eclipse environment or not? So yeah, organizationally, it's challenging to pull this forward at all, especially with COVID. There is a possibility that we might even try and have a face-to-face meeting early in the new year. That would be, I think, very useful because, frankly, the people from these various different silos really literally don't know each other and don't know what the funding situations are in their other silos, in very many cases. So yeah, from that perspective, I think a face-to-face meeting would be incredibly valuable. But yeah, if people on the call have other ideas, then shout. And as Martin said, if you happen to have connections to Brussels to try and make a project happen, then please shout loud. Martin, did you want to? I keep backing up to Martin, but many of these are indeed his slides. So did you want to say anything else on the summary?
No, good summary. I think we don't. The backup material is for everyone to read on a rainy Sunday afternoon, with some of the ideas which came out of the brainstorm. So
the backup material was very much whether or not the approach has to be, as it were, to go down to the lowest common denominator, or whether the approach can be to communicate at higher levels of abstraction. And at this point, lovely brainstorm ideas, but none of them are solid, and none of them have any code behind them to prove that the thing would actually work that way.
Perhaps the last slide is of the before last on the ROS. I think what you see in various industries is that in robotics, what started, 10 years ago or longer ago as real, just fun stuff is getting pretty serious. And they made the move already from ROS 1, which had a certain architecture. They took the learnings and moved to ROS 2, and they made some fundamental choices. And one of the very intriguing things I see in that framework is this data distribution layer called DDS, which is an OMG standard, which is actually a bit of an abstract communication protocol between different environments. And they use that as a foundational layer as part of ROS 2. And one thing what would be interesting for us to explore further is, we were talking about adapters or interfaces, and I think in Andy's keynote at the systems at the DiviCon Europe yesterday, he was even mentioning that there is a reference implementation or open source implementation of this DDS protocol available. So this might be interesting for us to see if we can communicate via that type of abstract bus, because this is a nice protocol, but it is not bound to a physical interface. It's an abstract communication layer, which is in that sense intriguing. So learning from ROS 2, connecting to ROS. You see that many initiatives, drones you were mentioning, but also in autonomous driving. I think Bosch is even making some vacuum cleaners using the ROS operating system, at least doing some trials. I'm not sure if that is going in production, but I've seen some presentation on that. So really something for us as a SystemC community to see what can it bring for us, especially in the lower levels of this picture, right? There is hardware in the environment, so we want to virtualize our hardware. So this is probably the software stack on top of us when it comes to a virtualized SoC. And then do we need all those layers? So perhaps from a simple model, we can already directly connect to the ROS infrastructure without the need for a full-blown Linux or so. To be seen, to be studied. So I think this is interesting stuff. We put in the link. So for those interested, yeah, take a look. I don't know what the current status is in OpenADX, Andy, on ROS2, because I think it was also on your radar screen, right?
Yes, if you look on the car behind me, this is powered by ROS2 with the open source implementation of the OMG DDS standard. So the winning team, so last weekend was the final race for the India Autonomous Challenge. And the winning team put everything in the open. So basis really ROS2. The latest release, Galactic Geochronon. And yeah, they use OpenADX technologies, and that's really cool. And there are also some open operating system out there, typically some Unix derivatives. So for example, Ubuntu, you can use Ubuntu for a first step for free. And also some further stuff like Zephyr, Open RTOS. So there's a lot of stuff out there. And if you look on the hardware side, so there's also the Open Hardware Group, which depends on the RISC-V or the Core-5 activities. And there's also a kind of IDE currently under construction, means based on the Eclipse IDE. They providing here also in the open the first things. They have the, I guess it's also a reference board or a dev board they have, and therefore the first artifacts are there.
Do you know if that car is also completely virtualized? Do you know if there are virtual ECUs or a virtual model of the car or hardware, or is this all based on hardware prototyping?
No, they had, before they start to practice on the track, they had a so-called simulator race. So from ANSYS, they sponsored here the simulator race, and they provided also their simulator. And the first thing they did was real race. And maybe I found shortly the picture from today. So there's also in the ROS framework some simulator in there. So from LG, they provided the SVL simulator, and they have in there, especially for the race, also the complete Indianapolis Motor Speedway track, and also the cars in there. Just wait a second till it's loaded, hopefully. Just looking, and then I can show you shortly the picture so that you have a short impression. It's just a picture from the simulator. I have not a real simulation instance here for you. Just picture out of that. But
Laura,
that you
can you make sure that Andy can share?
Just a second. First, I have to find the slide.
To be clear about, while you're doing that, to be clear about the DDS thing, which is very tantalizing, but it's not yet clear whether it would work. The thought is that, well, were we in the SystemC community to use something similar, would that mean that you could potentially connect an application based on DDS to a hardware simulator without kind of, the two simulators, as it were, could connect together without necessarily having to go bottom out through the hardware?
Valid question. That is, I think, part of the study, right? To see whether this stack, you need a full stack or you can have a minimized stack.
So you can see my screen. Maybe it will change if I change now.
Yes, we can see your screen.
Okay, so you can see the same stuff. So I have currently 3 screens, and I guess the one I shared at the moment is not the right one. But you can see here all the data they have within the race car, so that you can see here this round per minute from the engine, the current transmission status. You can see here the Indianapolis Motor Speedway. You can see here a bit of more pictures. So yes, they have here a simulation built exactly for this use case in the open.
But there is no notion of SOCs where software is running on, right? This is somewhere already abstracted away, I suppose.
Yes, this is abstracted, but yeah, if you would like to simulate everything, then you have a real huge simulation, I know. But to make that in several steps, I guess you can have then some on the SOCs, you can have some on the next steps, and I'm really sure that the Open Hardware Group is also working in that area more on the SOC side, because they want to, or more on the instruction set side at the moment, and building here some controllers out of that. So I guess they are really close to that what you are looking for. Not sure on that, but this is my guess.
I would have thought that they would need to, and I think that's exactly what we're, as it were, targeting at, to make sure that SystemC can be used as the stack for the system on chip simulation, or at least aspects of that can, where that's appropriate, and it will connect in and link in with other things, and yeah, such that you can have an island of SystemC code, an island of FMI, FMU, and next step as well at the top. Unsurprisingly, we've reached the top of the hour. Are there other questions? I haven't seen any questions in the chat. Oh yeah, there are some. Yeah, there's FMI, FMU.
Yeah, there's a question on the Scheme interface, which is used by connection emulation with simulation frameworks.
Well, I think it's limited, isn't it, to some vendors? I'm not sure we've incorporated that in the open source.
I think that one of the things we need to study is what type of interfaces does exist indeed, and at which abstraction level, and whether they suit our use case. At the end, yeah, there is a lot of technology, but we need to be clear what do we try to solve at which abstraction level. So first we need to know what we want to do before we can pick standard A or standard B.
I would put one last call out, which is that if you are interested in this problem, or recognize this problem, then by all means get in touch with either me or Martin. And a huge thank you to Martin for putting the slides together.